Okay, so let's get started. So for limiting reactant, basically you are trying to find out the reactant that determines how much product is formed, right? So limiting reactants will determine how much product is formed. And in this way, it's going to be important to find out who the limiting reactant is, because only when you find out the limiting reactant and how much you have, then you'll be able to determine the amount of the product that's formed. And so we have a sample question here. How many grams of water are formed when you have 12.0 grams of hydrogen reacting with 17 grams of oxygen? Okay, so we've got to find out the grams of water, and you start off with 12 grams of hydrogen with 17 grams of oxygen. So the first thing you have to do is always to write an equation, because only when you write an equation you can find out the stoichiometric coefficients. So we have 2H2 plus O2, and that gives you 2H2O. Okay, so I don't think the state symbol matters here. Like I said, we're more curious about the mass of the water, and that doesn't really matter which state the water is in. So if you put an L, if you put in G, they're both fine. Okay, so the first step is to write down and convert both of the reactants that you have, okay, into moles. You start with mass, but you see different substances, they have different molar masses. So it's very important to convert to moles so that you are just looking at the number of particles and not looking at how much mass you have, but instead you are looking at the number of moles that you have. That puts everything on an equal comparison, right? Okay, you're comparing everything on the same basis of just numbers rather than masses. Okay, so the first thing you have to do is to find the number of moles of H2 and the number of moles of O2. Okay, so for N of a substance, it's going to be N is equal to mass over molar mass. So for N of H2, it's 12.0 divided by the molar mass of hydrogen. So that's 2.02. Okay, and so that's going to give us the number of mole of so it's going to give us 5.9406 moles. And the next one will be oxygen. Oxygen is going to give us 17.0 divided by 32.00. Okay, because O2 is having a molar mass of 32. So 17 divided by 32, that gives us 0.53125 moles. Okay, so I have these two number of moles. Now the next step is to divide the number of moles by their respective stoichiometric coefficient. So what is the stoichiometric coefficient? We are actually looking at the number that is in front of the substances that are present. So in this case, the stoichiometric coefficient for H2, it's 2. For O2, it's just 1. Okay, so that means you have to divide the number of moles of H2 by 2. And that gives you 2.9703. Okay. On the other hand, for oxygen, okay, it's just 0.53125 divided by 1. So that gives you 0.53125. All right. So it's very important to know the purpose of doing this. This is so that you are finding out how much is one portion. Okay, so meaning to say that in hydrogen, okay, it's actually 2 portions. But if hydrogen were to be the limiting reactant, okay, I'm not saying that hydrogen is the limiting reactant. I'm just saying if it were to be the limiting reactant, then 1 unit of, or 1 portion of hydrogen is 2.9703 moles. On the other hand, if oxygen were to be the limiting reactant, then the 1 portion of oxygen is 0.53125 moles. That's very important because you need to use these values to find out the number of moles of products formed. Okay. But that's not the end, right? So that goes into the third step. After you find step 2, you have to do step 3, which is to conclude on who is the limiting reactant. Okay. So in this case, we are looking at the limiting reagent being the smaller one. Okay, so being the smaller quotient must be the smaller one. Okay, and then the larger one will be in excess. What do we mean by quotient? Quotient is just the answer that you get from the division in step 2. Okay, so the answer of the division is the quotient. So you have to find a smaller quotient as the limiting reagent. Why is that? Because it's got smaller, right? So therefore it is the limiting reagent. So that's just numbers. Okay, you're just working around with numbers. Okay, the smaller it is, then the more limiting it is, right? It's going to limit you on the number of products formed, the number of moles of products formed. So in this case, O2 is the limiting reagent. While H2 is the excess. So which means oxygen is going to determine the amount of water that's formed. Okay, so we have to use this, right? Okay, or you can say we need to use this. Whichever way is fine. Okay, so the last one is using the limiting reactant that we found, then we have to find out the answer. And the answer is basically how many grams of water we will produce. Okay, so the first thing, of course, is to find out the number of moles of water. Okay, so H2O, the number of moles of H2O is actually twice the number of moles of oxygen. Right? You can see that it's 2:1 from the reaction. So that means the number of moles of water is 0.53125 times 2. So that is 1.06 But that's just the number of moles. We need the number of grams. So that is the mass of water. And that is actually number of moles times the molar mass, right? So it's 1.0625 times 18.02. So that gives us 19.146, but let's just round off to 19.1. Okay, because it's 3SF. Okay, all the values are 3SF, so you just round off to the same number of SFs. Okay, so to summarize these, the most important step would be 2 and 3. Right? Okay, basically you are dividing by the smaller, you're dividing by the respective stoichiometric coefficient. And so then you can get how much one portion would be. Okay, and by looking at the smaller quotient, then you determine the limiting reagent. All right, so thank you guys for your time.